Hello, everyone. Welcome to the Tech Gig webinar. Thank you for joining the session today. The topic of today's talk is using data for real-time analytics. It'll be a 1 hour session with around 40 to 45 minutes for the presentation and the remaining time for the Q&A. So if you have any questions, please send them to us using the questions tab on the GoToWebinar control panel. I am Sukriti, the moderator of this session, and it gives me great pleasure to introduce you to our guest speaker, Markus Thurner, Principal Software Engineer from Cimpress. Markus is the engineering lead in the data team at Cimpress. He has been associated with Cimpress for the past 10 years with extensive experience in manufacturing and shop floor processes. He joined the data team almost a year ago. So without any further delay, let me introduce you to our guest speaker. Over to you, Markus.
Thank you for the nice introduction and welcome to my talk, Small Data, Big Data. Before we start on the topic, I hope everyone in the call is safe and healthy. I'm sure the current economic and social changes are drastic to everyone's personal and professional life, and I truly appreciate you take the time to listen to this talk today. And on my side, I tried just to add a little bit of fun to keep everyone entertained. And yeah, if you didn't understand what I was saying, then it was most likely a joke. So with that, let's start. I already got very nicely introduced, so thanks a lot from that. Potentially just to add here a little bit, I'm based in Switzerland, in Europe, and my passion is really about delivering sustainable solutions with a product-first mindset and an engineering team that loves technology. And here's the address from Twitter where you can find some of the personal thoughts, and feel free to contribute or contact me through that. So let's get started. I'll start by outlining our challenge. It will contain some context of who Cimpress and its businesses are, how they are organized, and how this drives some of our decisions. However, most of these are generally applicable to most situations, but this context will help clarify some of the aspects and some of the use cases we are having. To solve our challenge, I'll focus on two key aspects today. One is us as humans, the mindset we are having, the team alignment we are having, and technology. I'm really passionate about talking about the first aspect, mindset and culture, and bringing together the team to deliver best-in-class solutions. I could talk for hours on that topic, but I'll try to keep it reasonably short, and I'll move into technology, giving you a super high-level overview of our data platform, our technology choices, and then, as a key part, focusing on how we build a serverless ingestion pipeline that is more or less how to send data into a data warehouse and a data lake in a very highly efficient and cost-efficient way. I'll round it up with a few analytical reports about our very own data platform, so you see a little bit the scale of what we are operating. So that's Cimpress and its businesses. Cimpress builds and invests into mass customization businesses. Mass customization is about producing fully customizable and personalized products, from visiting cards to flyers to brochures, mugs and t-shirts and much more. So everything that a small business owner needs. The businesses operate fully autonomous in their markets, serving their customers, and as Cimpress acquires more businesses, integration will actually be fairly simple because most of the integration is just for financial reporting, but everything else is fairly loosely coupled. Most of the businesses operate in Europe or the US, with the exception of Vistaprint as a fairly global player, Printy in Brazil, and YSD in China. For those based in India, the majority of you in the call, you might want to check out Vistaprint.in, the only company on this list with a production facilities and customer support based in India. And that's the best way to get an impression of the breadth of products that can be personalized and the complexity of the business that we are trying to build up here. And just a funny side note, I'm obviously getting paid for all the advertisements here. Anyway, there is a fairly small set of central teams. I think in the overall workforce, it's like 5% of the employees. And among them is a team called Cimpress Technology. Cimpress Technology builds and operates the mass customization platform. This is a technology platform that allows the businesses to level up their IT investments from e-commerce to manufacturing to even integrating third-party suppliers and so on. Cimpress Technology has over 300 people, mostly software engineers or people working very closely with them, like dedicated product owners, UX engineers, or some with the title leader in it. We're based in many locations across the US, Europe, and India. And in India, it's in Mumbai and Bengaluru. The Cimpress data team where I'm working at, and this presentation is about, is part of Cimpress Technology. Our data team has 21 team members across 5 locations originally, but well, with this whole lockdown of the economy in the countries we are based in, we're actually now to 21 home locations. So we operate in 3 time zones that are painted here on the world map with flags, and we are working in a highly distributed fashion already through the past years. But that said, getting from 5 to 21 locations was still a challenge. This should be all the context you need from our organizational perspective. And the key point I want to have you take away is that those businesses are fully autonomous. And this is a key decision aspect for some of the technology choices I'll elaborate later. Speaking of which, of those businesses, let's have a quick look at the high-level architecture of the businesses and how this evolved over the past 5 years. That's roughly 5 years ago. Well, in some cases, even just 2 years ago. I mean, super simple to understand. Also, just 2 executables to deploy, one for the website and one for manufacturing. I'm not going into details how this looks behind the scenes when hundreds of engineers try to tame the very same beast at the very same time. Fortunately, the world has moved away from this model for most companies, and I hope for all of you in the call that you also have the chance to make this move, and I'm really glad to be in this situation to be more like in this model. We're having hundreds of independent microservices built by various different teams in different locations, and they're typically clustered around some areas like e-commerce, logistics, artwork, and many more that I can't even list on this slide. It's 180-degree different than before, but this model allows us to move fast, independent, and fits the needs of finer-grained solutions that our businesses need depending on the solution aspect. So with that in mind, let's summarize the challenge we are having. We have many data sources that produce and own data in various technologies. It's a level of scale and complexity that a central data team won't be able to deal with, nor even try to reach out to those teams. It's just a complexity that is too big. So besides having many data producers, there are also many data consumers, often very far away from the producer, like in a different time zone, different country, in a different context, like a producer in a technology team and a consumer at the business side in a different country. So we are challenged with creating something that works in a self-service way that producers and consumers can collaborate to create and consume data products without the need of a central BI team for reporting nor for gatekeeping of data flow. So giving our diverse businesses data privacy and permissions are an obvious other high important factor, and among many others that all of you are having, like scalability, reliability, and so on. But I'm not going to focus too much on the common areas we are having here. All right, challenge accepted. That was what we said back in late 2018, early 2019. Let's build a scalable and reliable engineering solution. We have to build them while maintaining existing solutions. That is like changing the tires of a car while it continues to run on high speed. To allow us to keep the team size around 20 people, we also need a model that's lightweight on operational and support aspects and does not need to scale with the number of teams using this platform. So full self-service is one key aspect. And again, without decentralized and independent and an autonomous business, we settled for data being private by default. You send data in, it's only you who can see it. This is the level of privacy by default, what we mean. As a reminder, 2 key topics are for this presentation and also for getting us through this challenge is the mindset and the human aspect and the technology. So we are moving the first one, my personal passion, mindset, culture, and customer-centric engineering teams. Let me clarify with what I mean when I talk about engineering teams. Let's compare them to the other side of the spectrum, the operations team. There are many differences, and I could go on for hours or actually for days, so I'm narrowing it down to a few key aspects here. Effective versus efficient. Operation teams are highly efficient. They get a support ticket, they jump on team within minutes or even seconds, they fix it, they declare success. They have KPIs on how quickly they can solve tickets, how many tickets they can solve. They have leaderboards on identifying the hero of the week. Management supports this further by promoting the fastest. This is an incentive to beat this metric. So operations team, go further and script and automate every overhead away to become more efficient. In short, they automate all the ways that shouldn't even exist in the first place. This is true in an operations-led data team, or in a customer support team, or in a central IT team, you name it. Engineering teams, on the other hand, they hate support tickets. They address the root cause. Was it a bug? Let's fix it. Was it unclear documentation? Let's clarify it. Was it a hard-to-use user interface? Let's simplify it. They think in eliminating waste instead of automating it. They are not efficient, but highly effective in what they are doing. Low versus high noise level. Operation teams love escalations. They love when something is on fire. This is excitement. There's something to jump into and start solving. Once it's solved, this is often recognized in emails reaching a large audience on the heroic effort they did. And the worst, a week later, they have the very same escalations for the very same reason. Engineering teams, on the other hand, are led by people who avoid escalations at all costs. And if it happens, they look into the root cause, address the root cause to solve them for the long term. They will still thank their team for the heroic efforts on the weekend, but they'll recognize twice as much the work that was done to prevent the same thing to happen again. Better versus more is a bit of a continuation of my rant, but it's still a key aspect of a team's culture. Engineering teams want to have better tools, better skilled team members, better tests. Operation teams want more. They want more people on their team to handle even more tickets, more escalations, to have more processes and even more people. And in many companies, more often means more budget and more power on the decision table. One team puts the solution at the center and the other team puts the team itself. It's a very human reaction to want more. And for leaders who are humans as everyone here, is that they're acting the same and incentivize the more instead of the better. So giving recognition for less is really, really hard. But today is a good day for you to start doing that. So to round it up a bit, I wrote DevSecOps for the win. I hope all of you are familiar with the term DevOps, where teams and not only develop the software, but also run and operate it. Security is another aspect that teams typically deal with. Much more like product ownership, requirements engineering, user interface design, project management aspects, and so on and so on. So we actually potentially need a new keyword to win in this whole, or to define better what this whole DevOps theme means. So thanks for listening to my rant. And now to action. How does one actually adopt an engineering culture or move from an operations team to an engineering team? This will likely be different depending where you are and what change you want to achieve, but some of these ideas will help you in your situation as a team lead to drive for change. So this is a lot of what applied to us throughout all of last year. We made a large transformation from a very reactive operations team where escalations drove the agenda of the day-to-day, and until today, we are a very calm place where we build sustainable engineering solutions for the long term. So we started with the premise of leveraging the existing team. We saw that skill set was not the problem, but really how we as leaders of the team operated and directed them. So let's start with this. It's likely not the individual team member who are the problem. However, we adjusted hiring a bit, since that was the time when we were building up the team in Bengaluru. So adjusted interviewing to be a little bit more software engineering focused. New hires, they will not change your team's culture, but if your team adjusts its culture, the right skill set and mindset of new hires can substantially help. Next, let's delete all job descriptions. We're a small team. In fact, we're 3 small sub-teams in our data teams, and having one product owner, one scrum master, one DevOps engineer, one front-end engineer, one back-end engineer, it simply doesn't scale. If any of these people would be on vacation, your complete progress comes to a halt. So we dropped all role-specific descriptions, and everyone is now a software engineer at the data team. That said, all these tasks, they don't go away. It just we don't have dedicated roles for those anymore. Now, everyone is a DevOps engineer, everyone works on the back end, everyone works on the front end, everyone does product ownership, and so on and so on. Aligning incentives, that's on you as a leader or key influencer in the team. If you continue recognizing and celebrating those who extinguish a fire, you'll get more fires. In our case, we started to celebrate every time someone made progress towards either deployment automation or self-service. One was a key technical aspect on how we deploy and operate our software, and the other one was a generic key feature on how we want our platform to behave. Within weeks, people's wording changed and their actions adjusted heavily. It still took months, but today we are highly aligned on all those and even more key aspects. Stop the escalations. This is a short-term action you need to do to get into a political fight if needed with the outside world, but you need to give your team some breathing room to even start behaving differently. Just writing down, I want you to do X and not Y, but then continue asking for the short term. Obviously, that is too hard of a start. So your situation might be different, but it's still something that your team's habits are, and you need to break those habits. The end of projects is another favorite of mine. If you run projects, then you're incentivized to finish it. Whether on time or on budget, doesn't even matter. The point is to finish it, leave it behind, and move on to the next thing. This is an inherent problem that leads to short-term optimization of delivering a project where you shine, obviously. I mean, it's human, you do that. Creating product-centric teams, on the other hand, when you work on a product, it doesn't have an end. You start today, build version 1 this quarter, evolve it next quarter, do less a little bit in third quarter, and have a batch of features to deliver in the fourth quarter. And with every change you make, you think, I still have to maintain and operate this product in 3 to 5 years. So how do I keep shining in 3 to 5 years? Your decisions day to day are just completely different than running projects. Deadlines are, well, dead. Wait, what? I can keep procrastinating? No. Incentives around quick delivery and having a sense of urgency are still wanted. You don't want standstill, but you want the team to take the time to deliver quality over quantity. So instead of deadlines, assign a sequence. Be ultra clear in what feature to what quality is the most urgent one, and preferably lay this out in different timelines. What do you want to achieve this year, this quarter, this month? And it will be fairly obvious what to do this week and today. And focus on your multi-year roadmap and multi-month roadmap, and let your team deal with the shorter timeframes. And the last one in this list is definitely not exhaustive. It's going to be back to effective versus efficient rant from before. Being effective is hard to see initially. You fix a root cause for one bug, and then you get a few errors less per day, little impact overall. Then you do this again today, tomorrow, and the day after. Still, the first weeks will be painful where you see little impact to your users, but then a few months into, you'll see exponential change happening. As mentioned, your situation might be different. You might want to achieve a different transformation that requires different changes, but some of these points here are likely useful to follow in your situation. So internally, we declared success that we transitioned to an engineering mindset, and everyone on the team is aligned and excited. So what's next for us? Many things, but two of them stand out a bit. Since we don't have a role to blame, like, hey, product owner, or hey, DevOps engineer, that's your fault, we have to learn some skill sets. We successfully learned how to apply an engineering mindset and leverage and build up the skill set you need to deploy and operate and automate software. We have to do this now around building products, how to increase the quality of our products, and then to think of our users, put ourselves way more into the shoes of our users than we are doing today. And we want to go above and beyond their expectations, where we have a lot of room for improvements. This is just to highlight that you'll always want transitions and evolutions in your team. I see many teams and organizations where these happen organically and therefore lead to an undesired outcome. Be explicit on where the team should be in a year from now. Create incentives that help you reach that goal, and the results on your delivery, they will follow automatically. With that, I'm ending the first angle of this presentation, talking about humans and teams and alignment. And I'm sure many of you are now excited to look a little bit into technology, the second aspect of our challenge. Our data platform. First, we think in terms of the Cimpress data platform. We're not building the Cimpress data team, which is typical for a central BI team. We are building the platform. It's a small nuance in naming, but it helps everyone to understand and clarify what we stand for. The data platform is built on an API-first principle. Its key feature is full self-service that does not need a central BI team for many data activities, and is enhanced with various easy-to-use user interfaces. We have 3 focus areas and have partially aligned teams around these. Ingestion is about sending data into the data warehouse, storage to securely store and curate data, and consumption to provide tools to analyze and help users discover data. This is our high-level architecture. A custom data API to send data, Snowflake as the data lake and data warehouse solution to store and curate data, and Looker as the BI tool to model data, create data products, and help teams create reports or even connect machine learning applications to it. Both products are key to our platform due to their unique feature set that matches our needs and their innovative approach in the big data world. In reality, as you can guess, this architecture diagram is a big simplification. So let's go one level deeper. You notice a few more of those orange APIs and user interfaces showing up, and a few more Snowflake data warehouses. So let me explain. Snowflake has a few unique features that are key to enable a self-service data platform. First is their efficient way to store and query JSON formatted messages. This gives you very high flexibility towards evolving data schemas in a self-service way, completely done by the users of our data platform. Then the fact that Snowflake splits compute and storage as 2 separate units. Its storage is inherently very, very cheap. It allows us to store basically everything we want, and we only pay once we start querying the data for the compute that is needed. It matches then our analytical needs at the time. This was a game changer as we transitioned from AWS Redshift to Snowflake. On Redshift, we were spinning a large cluster that was mostly doing nothing but just store data. Even though, as a fair disclaimer, Redshift recently also released the option to split storage from compute. But this is not relevant anymore to us. Third, and this is the key feature for our setup with multiple businesses, is that Snowflake has data sharing capability between different completely isolated and dedicated Snowflake accounts. In our case, every business mentioned in the introduction slides has their very own Snowflake account, and their data is fully private to them. Businesses can opt in to share data selectively with other businesses or the central team like Cimpress Technology. And we've built a lot of tooling to make sharing data as simple as sharing a picture on a social network. And in fact, Snowflake recognized this need and is now also investing heavily into what they call the private data exchange concept, which you can read up online. Looker is another pillar that works the same whether you connect to Redshift, to Google BigQuery, or as in our case, to many Snowflake accounts. Looker distinguishes between 2 levels, data modeling and data analyzing. This is a key feature that allows us to develop data models in Looker once, and then leverage single models or the very same model to query the correct Snowflake account depending on your login credentials. So while I might see the data of one business, when you log in, you will see the data of another business. Even if we don't have such needs, this data modeling analytics split allows us to smoothly transition from Redshift to Snowflake by simply repointing the connection of a data model without touching any of the thousands of reports from hundreds of users. This is a time when all the engineering efforts are paying off, well, even to the point to make such transitions even possible, allowing us to adapt to a changing world today and in the future. And last, I mentioned we built various APIs and user interfaces, and while there are tens of them by now, a set of services around collecting usage, diagnostic, and through that lineage data is a key point, which will allow us to help with automation in the future. Knowing the most queried tables, the most used joins, and other key aspects allows us to automatically suggest what aggregate tables to create on what cadence, predict and optimize costs, and much more. And last but not least, with all these diverse data sources, who knows what's in the data lake? That's what our custom-built data discovery tool helps our users to find and discover. So let's look at the data API, where all those many microservices are sending us data. A lot of data. How did we approach this? What are its properties? I'll spend the rest of the presentation zooming in on the orange node here called Data API. So that's what we did actually within a year, and we replaced the existing infrastructure with a new one. In 2018, we had something that was partly self-service, so you could define a data format you want to send in, and if you were lucky, you could even deploy that. So really, I mean, we have heard stories that this even worked. But then every change had to go through us, typically a ticket where we had to spend a day on it, and every curation was done and owned by us, so an aggregate table or a specific view solving a specific business needs, all done by us, owned, and due to our involvement in those aspects, even recommended by us. So as we worked closer with the data sources, we were acting as a central gatekeeper, not something we wanted to do, but something that naturally came to us given the infrastructure and options we had back then. We had heavy servers, Redshift, I already mentioned. Back then, every bit of data you added required you to scale the cluster to more nodes. We ran the first version of our API on virtual machines, a custom Kafka cluster, a very large and expensive Spark cluster, and a Redis cluster. Summing this up, we're talking of $10,000s of dollars per month of server costs, mostly manually maintained, hard to upgrade, and throughout 3 to 4 years of running this, we did not even achieve that 100 different teams or services are sending us data. We were at about like 1 to 2 new services per month. And if you remember one of my initial slides, we were running hundreds, if not thousands of microservices across our whole platform. Fast forward 1 year, we now have a solution that's API first with an easy to use user interface to provision a new data stream fully self-service. Also, we now have our curation layer directly in Snowflake, which allows users to evolve, merge, and aggregate data to their needs of data freshness and query performance. This moved us into a position where we don't ask questions what users send. We have something lightweight, completely serverless from our perspective. We don't manage a single server ourselves, but we obviously leverage a lot of managed compute power. All of the managed compute power is also compatible for full auto-scaling from our API down to Snowflake's built-in compute. If we use it, we pay. If we don't, it's free. This is a scaling flexibility that comes with a cost, but the savings are many times higher, which I'll show in a minute. All right, here's a test on how many AWS symbols you're able to recognize. All right, I'll give you a few hints. This matches our architecture. It's our actual architecture without too much simplification. True, there's a lot of complexity how we orchestrate those services, but from a pure data flow perspective, that's the hops that a message takes. Let's go through it. We leverage AWS API Gateway to expose our API to the world so other microservices can send data to us. We process the requests on AWS Lambda. It's only a few lines of code that run a few basic checks and then forward the message to Kinesis Firehose. Firehose is a service that buffers messages for a given time and then forwards a single larger file to S3. So for example, if a service sends us 1 message per second, we'll have 60 messages after a minute and 600 messages after 10 minutes. If the stream is set to a 10-minute delay, the file that we are sending then to S3 will be a single large file with 600 messages in it. We then use Snowpipe, a compute process offered by Snowflake to load data from S3 to Snowflake. From our perspective, it's just configuration and all the magic is done by Snowflake. Once it's landed there, we continue processing it further to provide some auto-curation features such as deduplication of messages or latest entity tables. Again, a bit of standardized and automated configuration from our side, and Snowflake runs this without any operational overhead from our side. One connection to all of these is AWS CloudWatch logs, events, and alerts, which we use to get alerted in real time if something is wrong. So let's quickly summarize. It's end-to-end serverless using a lot of compute power managed by AWS or Snowflake respectively. we're attractive on the cost base. It's 0. If nobody sends us messages for an hour, this 1 hour was completely free. It's a scaling leverage upwards and downwards that is impossible to achieve with custom managed scaling, where you always need to keep some buffer. Our scaling is on the message level, the smallest granularity possible. Our operational overhead is not 0. We still need to monitor this pipeline, but we don't need any Linux expertise, any dedicated security expertise to secure and upgrade virtual machines and operating systems. We don't need an engineering or release engineering team. It's a simple system to maintain. Our deployment is fully automated, so every data stream that gets provisioned looks exactly the same. No room for human errors in configuring systems or a drift between how individuals are configuring details. As implicitly mentioned before, some of the advanced features are done on our API directly, or in the case of a first level of data curation on Snowflake. The system also allows us to make data available for analytical reports within minutes. The shortest times we allowed to configure is 1 minute, the longest 15 minutes. So the whole company is used that if revenue data comes in, it will show up within minutes, or depending on the curation steps in between, at least within less than 1 hour. Let's say on a quarterly report that our CEO is looking at. And given these economically challenging times, it's a game changer compared to those who are still doing monthly or partial manual reporting. I mentioned we still need monitoring. We are currently 3 people in our team who run this aspect of the data platform. So among us 3, we guarantee first level support 24/7, 365. And since we like sleeping and nice weekends well, we try really hard to keep the alerts at 0. No, not at 1, at 0. I mean, have we been down? Oh yes, twice. Let me just give you some context there. Well, actually 1.5 times. Once back in September last year, it was our own stupidity. I mean, we simply didn't test what should have been tested before merging a pull request, and we quickly rolled back, but no, that was not fun. And as you can guess, we have tests now that will prevent at least this level of stupidity. The second time, we were like 10–20% down. It was a partial AWS outage of the API gateway to Lambda connection. Nothing we could do at that point, but it lasted for 2 hours. So this shows complexity about your dependency on a service provider. But even there, we have opportunities to evolve. We can work around this by running the service more globally distributed, having a fallback infrastructure, and so on. But we also have to recognize that this is such a small downtime. The team of 3 or 4 we are currently working on this is impossible to achieve this level of service. Explicitly, we are monitoring the 500 HTTP error codes from API gateway. If it's not a 500, it's guaranteed to be in Kinesis, and they guarantee that the message made it to multiple availability zones at AWS. Then we need a guarantee that the message gets from Firehose to F3 before it gets dropped from Firehose. As we started this new system, we started very conservatively by monitoring row count, so matching the number of lines in files on S3 with the number of rows on Snowflake. As we built up the confidence and understood Snowflake's Snowpipe monitoring better, we discontinued this expensive non-scalable monitoring and are now only monitoring that all files from S3 are successfully loaded into Snowflake. And last but not least, we are ensuring that the scheduled tasks on Snowflake are executing. So we are monitoring the staleness of tasks, ensuring that none of them falls behind a given threshold. Through that monitoring, we also learned a great deal how accurate Snowflake tasks are and their absolute best-in-class availability of compute power. So that was an overview of our serverless ingestion pipeline, and I rolled it up to look at some of our metrics that we are, to be honest, also quite proud of. First, I mentioned in the first years of service on the old API, within a few years, we did not reach 100 streams by a large margin. So now within 1 year, we made it to well over 200 data streams that send messages on a daily basis. And it's many more hundred streams that are configured either to be used in test environments or simply to send data less than daily, like some data that only need to be updated weekly or monthly. Talking about self-service, we only had chats with users as the very first streams onboarded. Back then, provisioning was just an API call. Now we have an easy-to-use user interface backed by reasonably well-written documentation that allows users to play with it and achieve their production-ready goals. Number of messages. We hit a big celebration back in July last year. Wow, someone big started to send messages, like 1 million messages a day. That was a moment to celebrate the scalability of the system we created. The story in November was differently. We didn't even notice until a week or two afterwards. Yes, we jumped from like 5 million messages daily to 30 million messages daily and did not notice much. No alert, no questions, just a user who started to use our self-service data system more heavily. So yes, 30 million messages boils down to roughly 400 to 500 messages per second. And if you were to zoom in, we are basically oscillating between 200 and 1,000 messages per second of data being sent to our data lake. And here's something for helping you to influence the decisions you make and your decision makers: costs of infrastructure. Compared to our existing infrastructure that was very heavy on servers, it's at least a 50% reduction, if not more. Especially the up and down scaling on weekends, during nights, or after quiet season at the end of December is compensating for the higher compute costs during peaks. AWS just released saving plans, which will bring down costs further on Lambda. And you see one high runner of costs, the blue line here. And we're in fact working on a merge request these days to basically eliminate this cost. This will bring down the cost by another 50% or more. And so starting from in a few days from now, we expect to run this whole system with less than $2,000 per month of infrastructure cost, with close to zero operational overhead, assuming a run rate of about 500 messages per second. We believe this is a cost base that's hard to beat in the whole industry, at least given exactly that amount of scale what we are currently having. Did we solve it? Can we all go on vacation now? Obviously not. It's not a finished project. We're owning products which need love and care, and I only talked about how simple and efficient we made sending data, lowering the hurdle for our users from very high to basically down to no overhead. It's, however, a path. Data curation and discovery will be a midterm focus to roll out the same easy to use and easy to understand impact across our data platform. And besides many ongoing challenges to help our businesses become more and more data-driven and simplify their basic analytical needs, data science and machine learning use cases are already applied today, but there's a lot of opportunity to simplify that and bring this to the masses within our company. To summarize, I talked a lot about us as humans, how to align team and transition a team from one belief system to another belief system, and in my case, the engineering mindset. I moved to aspects of why thinking of an API-first data platform ecosystem builds up long-term value that can be exponentially growing. Serverless for the win. And I know there are many critiques out there that it might be expensive and has other problems, but our cost overview for the current scale we are having is hopefully a very compelling argument with hard facts to your hand. And yes, I'm personally proud of our achievement of creating a self-service data platform. A data team that does not deal with data anymore, does not know which data are stored, is not a gatekeeper, but an enabler of allowing data producers and consumers to collaborate and create data products that deliver compelling business value. With that, I come to an end of my presentation. And before I open up for questions, one thing I'd really like to make now a big announcement of how many people we are hiring in India and across the world. We did, well, until very recently, and we'll do that again very soon. Please be a bit patient and check back on our website, or obviously connect with our HR and recruiting teams. The current economic situation just makes us obviously a little bit more cautious when and how much to invest, especially in long-term decisions as we invest into new hires, and we want to keep them for the long term. So yes, we'll be hiring again soon as the situations clarify. And with that, let's move to questions, and I hope I'll be answering your questions or a very similar question on this call. And otherwise, the best might be probably to ping me on Twitter. This is the easiest way to reach me without getting into a complicated relationship status on a social network. And I promise I'll answer, but it might take a bit. All right, so let me see if I can see the questions here. Let me just open that. All right. I'll try to come from top to bottom. Sandeep is asking, what is DevSecOps? DevSecOps is an enhancement to DevOps. It's not only development and operations, it's also security. So development, security, and operations. So the team own important aspects of security in addition to development and operations. Akash is asking, I'm a penultimate year engineering student. How can I fit myself with ongoing crisis in data-driven companies? I mean, you will probably get a very broad aspects of answers here, depending on who you ask, and I encourage you to ask many more people to get a diverse perspective. But data will become more and more important. One aspect, what I'm seeing on the horizon is, I mean, one thing is how you saw how the level of dealing with data is so much simplified these days. This is happening on a very, very fast pace around machine learning, where there's tools out there that do the model generation, which was 80% of the work of data scientists. It's just doing that fully automated. You will still need very special knowledge there and build that up to make really, really compelling solutions. But it's but the world is just moving in that direction. Tools will be a lot simpler, have very, very deep knowledge, and I'm sure companies will really ask for that skill set. Someone asks Snowflake versus Google Cloud versus AWS. That's from Deep. So there's only 3 good answers to that. Yes, take them all and use their best, and not to forget about Azure and other custom solutions out there, like Databricks and so on. So I explained a little bit the key aspects for Snowflake, which is around schemaless schema evolution, around the data sharing, which is the key part for us, and a few other aspects. Google Cloud with BigQuery, AWS with Redshift, especially with the announcement they made in the last year, they are continuing on that path. You cannot really make a wrong decision. Make the decision that helps exactly your team to achieve that. Can we keep transaction data as well in Snowflake? That is asked by Mohan. If you think that, so Snowflake is a data warehouse. It comes with some properties. So it's not a real-time database. When you think of this is where you hold your order data and you want to serve your web users in real time, you can probably get quite far, to be honest, these days, but this is not how the system is designed to. The system is designed to scan and analyze terabytes and even petabytes of data in a highly cost-efficient way. So you still want your SQL server, NoSQL database, whatever you have for your website and for your other applications. But yes, we are storing transactional data eventually for analytical purposes in Snowflake. So more or less the 500 messages we get, those are transactions on our APIs. So yes, from that aspect to store it for analytical needs, but no, it's not there to store it for your real-time needs. Deepak asks, what do you mean by following API-first principles within your data platform? Please answer once you get a moment. Sure, now is a good moment. With API-first is, think of that everything you want to access in the data platform, except through analytical reports that go through standard SQL, everything else should go through an API call. API calls that are following the latest RFC recommendations from how to deal with RESTful services. And you can find a lot of material on the internet. So once you achieve that and we did that, we rolled out APIs so people could use it on a self-service way to provision infrastructure for them, is we are now able to just build a UI on top of that. And I heard of some other teams that actually build some deployment automation for their very own needs, and they deploy some of the data aspects as part of their deployment. So as we have APIs, other teams can actually leverage those APIs. And it's kind of a key pillar to move on. Is Snowflake a data collection processing tool? Asked by Viresh. Snowflake is a data lake and a data warehouse combined. So yes, it is for data collection. It is for data processing through their built-in compute engine. It is way more. It is for analytical needs. It's the classical data warehouse tooling, what you're having. But also due to their split between compute and storage, you can just use it as your data lake in the company. Varun asks, how is security and integrity maintained? It's built into our team as the mindset, what I said with the DevSecOps. So the security is just part of what we have to deal with. How we deal with it is we are looking at, through automated deployments, the security is kind of built into our deployment script. So it's not that someone intentionally leaves a port open or a security vulnerability. So we start with zero permissions, and then we open it up depending on the services need. Shilpa asks, any quality checks in the ingestion pipeline? I don't know exactly what you mean by quality checks, but we are validating that is a valid JSON. We are validating a few key aspects, like if you have defined a primary key, we validate that the primary key's value is there, and so on. So there are a few quality checks what we're doing, but basically it's up to the data producer. If they send us wrong data, it's their problem. This is the interesting aspect of self-service. It's, this is not our problem anymore. We obviously need to create tooling, insights, and technical solutions so that others can deal with those problems. But it's in the very best interest of those sending data that they don't create big picture problem. I mean, things always go wrong, but they have the tool sets to actually fix those. Asha asked, how is the use of Firehose? Explained a little bit. So Firehose is basically just batching messages. So the problem with Snowpipe would be is Snowpipe you pay per file you're ingesting to Snowflake. And if we would pay for 500 messages per second, A, I don't think that Snowflake is built for that, and B, that would be horribly expensive. So batching those to hundreds and thousands of files, messages into a single file, to just have a single file load into Snowflake every few minutes, that's making it highly cost efficient. How does the cost compare if the load exists for 365/7 times 24? In that scenario, when you have very, very stable load and you have exactly 500 messages per second, all hours, or every minute, every second, you could potentially exactly provision some infrastructure like, your own virtual machine that is bringing down the costs and having the cost of that part of the processing. That said, that is just part of the cost, the pure compute on data ingestion. The rest is, fairly cheap of the Snowpipe loading. And so it's really about, a lot of aspects don't change, like how much data you get. So the data movement, this is not changing. It's also not changing the amount of requests you get on your API gateway or your load balancer. So many things actually are fairly fixed cost per message, and the compute is only when it goes down a little bit there. How big is your Snowflake in terms of data stored? We have nice reports. I actually don't know right now, but it's not overly huge. We are talking terabytes here. We are not talking petabytes. But that said, our data is very diverse. So I think it's huge in the amount of different data and curated data and tables and teams. Like we've had people on on the very same account and creating data completely self-service. So I think that is the big, where we are a little bit bigger than potentially other companies versus, some companies might just have fairly large data sets that they're loading and some up to multiple petabytes and other scales. Sharmila asks, to become a data science professionalist, what are the things I should learn? So data science is evolving heavily. There are a few key aspects, and some of them will be true in 10 years from now, and that is understand the business. What does the business want? What's the data product that the business wants to achieve? What's the relation of the stakeholders? And then, like, how do they want to see this thing? How they wanna what's the insight they want to get? I want customer insight. That can mean many, many different things of that. So truly understanding the use case and transforming that into technology, whether you are a software engineer, a data science, doing machine learning, or doing something potentially as a product owner or other things, like this does not go away. And this is a key thing that is really, really worthwhile having. The other aspect, the data science part is moving fast. Looking just a year or two back, most of that was understanding machine learning libraries, fairly low level, learning which model is best and what model applies best in what situation. Trial and error was 80% of the time used in that. Now you have tools that you just say, run me those models and overnight, and then in the morning it comes, this is the best model, and it has, I don't know, 93% accuracy. And you just pick this model and run it in production with a single click. That said, I mean, this is a simplification and it's in the early stages, but this showcases a little bit where the world is moving. So as a data scientist, you can actually work for such companies that create those tooling, and you really, really go deep into this data science and understanding the underlying aspects, or you go more into the business side and are really, really good at leveraging those tools in a very lean way and bring data science and data products to the masses of a company. Shailet is asking, I suppose you have continuous delivery in place. Can you talk a little bit about the test infrastructure, test types, the coverage you achieve? It's fairly simple. I mean, the principle is the smaller the change, the less the risk. If we have 3 deployments to production a day, we have 3 small risks, versus you have 1 big a week, then you might have a risk that is 10, 20 times as big, and everyone is scared about this weekly deployment. People create a pull request, and we thoroughly test on a pull request. I mean, some of that is automated unit test coverage. We have a little bit of integration tests to test some basic integration up to the Snowflake connection and so on, that we are sure that nothing is breaking there, or at least not one of the important aspects that we would not be able to recover from. And then you hit merge, go drink a coffee, and 5 minutes later, this thing is in production. It's that simple. It's no complicated system, no process around that, except if someone else needs to agree this change should go into production. Priyanshu asks, kindly provide some real-world scenarios to make some learning project, and they could help me for a hire. And I assume it's for a hire at our company or probably another company. It's really, the sky is the limit. Go out there. You can do certain things like make an AWS certification. Look into many cloud providers have a free tier. You might even be able to run a small cluster of something in a data science aspect or a data analytical aspect. There's free learning resources everywhere. There's so many aspects that you can learn, and I encourage you learn something. And you might have a student project or a project with your personal friends or something like that you could run, and just try to run. It doesn't need to be a success, this project, but it's a showcase that you see, hey, this is what I learned and this is how I apply it. I know it's a fairly generic thing, but it's really, this field is so big, And even our field, like we were focusing in and narrowing in on solving getting data into the data warehouse. The next step is curating data. And then the third one is, analytics and data discovery, fairly advanced already, but we can lower the hurdle a lot more there. And we haven't even touched machine learning, data science a lot. I mean, we do it, but there's just like the sky's the limit in terms of our own things. And like we are going to learn a lot throughout the next 1 or 2 years. So it's not that you would need to know everything, but you need to know the principles, how to apply them, and have, preferably have deep understanding in some of the aspects around analytics, around some of the data science things. Let me just browse through the questions. Some of them have been asked already. Sandeep asked, what are the monitoring services available on AWS? AWS has mostly CloudWatch is their key monitoring solution, and that is where all the AWS services are connected to. Swapnil asked, can manual intervention be possible at certain levels in real-time analytics? I'm a little bit unclear what you mean, but in our case, we have everything fully automated, and we don't want these manual interventions. We have, once the data are on S3, which is kind of the critical path and has a little bit of a timeliness thing, we can recover fully because like we store them forever, and we could actually reprocess a lost data stream. Yes, this is not real-time interventions, but it's something that we haven't really thought of and hasn't been a big ask. Hold on, give me a second to browse through those questions. Shruti asks, also, is Snowflake more of data visualization, or it's equally utilized for data collection from desktop and web application? Snowflake is just a data warehouse. If you want to visualize data, you need to go through, Looker, Tableau, ClickView, SQL Server that has some reporting connections. Excel might be the simplest case to connect to and do Excel reports connected to Snowflake. So Snowflake is kind of the data warehouse where you store the data. Rakesh asks an interesting question. How can data analytics help in crises like COVID-19 and the current economic situation? There's two specific examples. One I mentioned a little bit is just like our reports to the CEO around revenue data are there for him to consume within way less than an hour. This is giving him real-time certainty about what's going out there. And I think this is just giving you don't need necessarily real-time up to a second or millisecond, but something that is a few hours behind at most. And accurate that you use for your quarterly reporting, monthly reporting, all those type of things. The other aspect is an interesting one. I mentioned Snowflake's data exchange, and through their data exchange, one company called Starscheme actually released COVID-19 case data across the world, and we are mounting those, and now our analysts are leveraging those data and combining them with potentially country revenue data. So we are now getting real-time insights, leveraging open source or free to use data from another provider that is not at us, and combining that with things that we are having internally. About engineering culture by Piero, don't you think that having all generalists in a team versus specialists would lower the overall quality level of a wide set of software engineering required skill sets about architecture, development, product management, requirements engineering? How do you cope with that? Yes, this is true a lot. And while I said everyone is a software engineer, or just call them engineer, don't even need the word software, this is an important first step to say everyone is equal. If something is down, everyone needs to jump on it. If someone needs customer support, everyone needs to jump on it. That said, internally, we have different personalities, different skill sets. Some are naturally strong at talking to our users. Others are naturally strong at documentation. So people evolve into that. It's still team-owned. If that person is out, it still gets done. but it's just like what the person likes. So this is, I made a lot of black and white statements, and the real truth is somewhere in the middle. But I think the point I wanted to make is move away a little bit from making those role descriptions that are tied to the user. So with that, I think that was really a nice question to round this up. I have here many more questions that were coming in, and I try to answer them on so either some online channel or work with the team here that hosts this Tech Gig and this webinar. And thanks a lot for your participation. I'm really excited to have all of you in the call. Thank you for joining to the end, and I hope it was something useful for you, either on engineering team and culture, or just on technology. And it's one little aspect of the big data world, and it hopefully inspires you what you can achieve with a reasonably small team when completely aligned to something that you want to achieve.
Thank you
Thanks a
so
lot.
much. Thank you so much, Marcus, for this really empowering and motivating session today. I would also like to thank all our participants for making this webinar a great success. This session has been recorded, and the recording will soon be available on techig.com. Thank you, everyone, for joining us.